Hello, this is Project Secret Agent for Behavioral Biometric Continuous Authentication, or what does your key press rhythm say about you? This research is being conducted at the Cedar Lab at the University of Wyoming, which is directed by Dr. Mike Borovchik, and we've been mentored by the graduate students Danny Radosevich and Shea Wolf. The current team members of Secret Agent are Jarek Brown, Faith Coslet, myself, and Adeline Rachard. We are all currently undergraduate students of the Computer Science Department at the University of Wyoming. And if you'd like to learn more about any of us, these QR codes lead to our LinkedIn profiles. Now, for background information for Secret Agent, this project is based off of a prior CEDAR project called Spy Hunter, which was a continuous authentication program. Now, continuous authentication is as opposed to a one-time authentication method like a password. For example, when you give a system a password, you are able to use that unlocked system until you log out. But a continuous authentication method actually repeatedly validates the user during the use session of the system. So if it detects any difference in behavior, which would signify an invalid user suddenly using the unlocked system, it will lock that system, which is a more secure method than one-time passcode authentication. And our Spy Hunter continuous authenticator uses the method of keystroke timing dynamics or typing behavior, such as the average key press time a user has or the timing they typically have between key presses.
My name is Jarek Brown. I'm a computer science undergrad here at the University of Wyoming. The goal of Secret Agent is to find vulnerabilities within the Spy Hunter system. We would obtain keystroke timing data from a user, which would then be used to spoof the Spy Hunter authenticator. Secret Agent uses classifiers to analyze the 5 timing values for each key press combination. It then uses that information to spoof Spy Hunter by pretending to be a user and then gaining access into a system.
Hi, I'm Adeline. For the results of our project, we noticed that Spy Hunter had the issue where users were evaluated differently based on whether they were genuine or not, which falsely boosted Spy Hunter's accuracy. Therefore, before we could begin spoofing, we needed to update Spy Hunter. Some of the new attempts we tried were several different classifiers. We tried one-class SVMs, elliptic envelopes, and isolation forests. The best results we've achieved are a false acceptance rate of 13% and a false rejection rate of 15%. With these rates, we are able to reject adversaries at an average of 53 keystrokes. Our false acceptance and false rejection rates are pretty on par with the current field, and our number of keystrokes is pretty low, which we're excited about. But we are still trying to get our false acceptance and false rejection rates lower. In terms of challenges and future work, some of the challenges we've run into include updating the Spy Hunter code to ensure that the authentication code can be separated from the cross-validation code. Additionally, in terms of future work, we've noticed that running a keylogger in a virtualized environment can be tricky. And additionally, we need to be able to ensure secure testing, meaning that we're able to secure all of the data we collect from any participants, because that is sensitive data that can be used to authenticate them, and any key press data we want to be able to make sure we can secure. Additionally, we need to make sure the spoofed timing data passes Spy Hunter's low-level security checks. This essentially means that any data that we generate or collect needs to pass the 3 equations below in order to just be able to make it past that very basic security check. Thank you guys so much for listening to our presentation, and thank you for your time.